characteristic of equilibrium state. What happens at equilibrium? Equilibrium is the condition where rate of forward reaction equals to rate of backward reaction. That means speed of forward and backward reaction is same, and definitely this is going to happen when both the reaction is happening, and such reaction is known as reversible reaction. All right. So first condition for equilibrium to achieve is a reversible condition. Right. A reaction is reversible, then only equilibrium can be achieved. Equilibrium can be achieved from either direction. If you start from reactant side, equilibrium condition will be reached. If you start from product side, equilibrium will be reached. So equilibrium is the condition where the reaction finally reaches. All right. So here in physics, you must have heard that condition at which something is at rest is known as equilibrium. But in physics, equilibrium is a state of dynamic movement. That means reaction is not resting. In chemistry, we do not rest. In physics, people think that equilibrium is achieved once rest is achieved. But chemistry, we think keep working, keep moving. So our reaction also keep moving at equilibrium. It is moving in equal directions, right? With the speed, same speed, and it is dynamic in nature. And if you take gaseous reactant and gaseous products, then the reaction should be carried out in a closed container. All right. So this is a very important point. Closed container is required. Next few points are there that it can be achieved. We have discussed it is dynamic in nature. Equilibrium state is not changed by a catalyst. If you take catalyst at the beginning of the reaction, then reaction is achieved faster. But if reaction is at equilibrium, catalyst addition does not make much difference. All right. So this is covered, and next we have that it is achieved in closed space. We have already discussed everything out of that. So here this graph explains the same thing which we have discussed. If you have started from reactant and product H2 and I2, if you took, then also equilibrium is reached, right, after a certain point. Next, if you start from this side, then also equilibrium is achieved. Either you start from reactants or products, after a certain time equilibrium is achieved, where the speed of forward equals to speed of backward. All right. Next, we have to discuss a constant called equilibrium constant. Equilibrium constant is written as Kc, Kp, right, or K equilibrium. You can write in any of these ways. How you have to write? You have to write. Let me take one example. A reaction is like this: A plus B and gives you C and D. Now, equilibrium constant Kc is written like the concentration of cap C raised to the power of moles into concentration of B raised to its moles, and below it concentration of A, the reactants raised to the power of its coefficient, and concentration of B raised up to the power of its coefficient. So this is Kc is known as equilibrium constant. And what are these values in the square bracket? That means concentration of C, concentration of D, concentration of A, concentration of B. Concentration, the square bracket represents concentration, or you can say molarity, or you can say active mass. So you can calculate concentration of C by putting moles of C upon volume of container if it is a gaseous mixture. Similarly, moles of D upon volume of the container, moles of A upon volume of container, moles of B upon volume of container, which must be given in the yeah, any question asked, right? Next, there is a small law called law of mass action. That's a very basic law. And what does this say? For example, there is a reaction A plus B gives you C plus D. So what law of mass action says? That rate of forward reaction will be equals to Kf, that is rate constant, into concentration of A into concentration of B. Similarly, for backward reaction, reactants will be C and D. So rate of backward reaction will equals to rate constant of backward, that is Kb, into concentration of C and concentration of D. Alright, at equilibrium Rf will be equals to Rb. Then we can derive this formula very easily. That's it.